discuss the Phasor diagram of Maxwell's inductance capacitance bridge. Before writing any Phasor diagram, you have to be aware of these three concepts. Okay, that is, if the circuit is completely resistive, then current and voltage will be in phase, and if the circuit is inductive, then current or voltage leads the current by an angle of 90 degree, and if the circuit is capacitance or a capacitive circuit, then voltage lags current by an angle of 90 degree. If it is resistive, voltage and current will be in phase. If it is inductive, voltage leads current by an angle of 90 degree, and if it is capacitive, voltage lags current by an angle of 90 degree. Now we'll start analyzing the circuit. Here, this is the first arm. What is the voltage drop across this resistance? The voltage drop across this resistance is I1 Rx. And what is the voltage drop across this inductor? I1 omega Lx. This is the voltage drop of these two. Now coming to this arm, what is the voltage drop here? I2 R2. Now coming to this arm, what is the voltage drop here? I3 R3. Now here the current I4, it is splitting into two parts. One is the current which is flowing through the capacitor C4, and another one is through the resistor R4. This current is called as IC, and this current is represented as IR. So here I4 will be equal to IC plus IR. Now under balanced condition, what will happen? The potential drop across E1 will be equal to potential drop across E3, and the potential drop across E2 will be equal to the potential drop across E4. Now what is the expression for E1? What is the expression for E1? E1 is equal to I1 Rx plus I1 omega Lx. This E1 is combination of this resistance and this inductance, right? E1 is equal to I1 Rx plus I1 omega Lx. And under balanced condition, what will happen? E1 will be equal to E3. E1 will be equal to E3, and E2 will be equal to E4. This E2 will be equal to E4. Now, what is the value of E3? Potential drop across this E3. Sorry, E3 is this. E3 is equal to I3 R3. E3 is equal to I3 R3. Now, under balanced condition, no current flows through the detector. That is, whatever the current which is passing here will flow to this arm, and whatever the current which is passing here will flow to this path. Right? So the current I1 is equal to current I2, and the current I3 will be equal to current I4 under balanced condition. Now, what is the voltage drop across this E4? Now here, the voltage drop across these 2 points will be same as these 2 points. The voltage drop across this capacitor is IC upon omega C4, and the voltage drop across this resistor is IR R4, and this is equal to E4. Now let us start writing the Phasor diagram by keeping current I1 as base. Okay. Now, this is current I1. I am keeping I1 as base. Now, what is the drop across this resistance? I1 Rx. This is a resistive load, so voltage and current will be in phase. That is, this will be I1 Rx. Now next, moving to this I1 omega Lx. This is a inductive load. So this is voltage, current should voltage leads the current by an angle of 90 degree if it is an inductive circuit. So this is I1 omega Lx. Okay. This is I1 Rx, and this is I1 omega Lx. Now the combination of this is E1, right? E1 is equal to I1 Rx plus I1 omega Lx. E1 is the resultant. How to write the resultant? This is a resultant, that this is E1, and under balanced condition E1 will be equal to E3. So this will be equal to E3. And what is the value of E3? Voltage drop across E3 is I3 R3, which is also equal to I3 R3. So we have completed this arm as well as this arm. Now, next, under balanced condition we have one more condition, that is current I1 will be equal to I2. Current I1 will be equal to I2. If this is current I1, this will be equal to I2. What is E2 then? E2 will be equal to I2 R2. This is a resistive circuit. So if current is here, even the voltage will be here only. That is I2 R2. Voltage and current both are in phase for a resistive circuit. Now, next, coming on to this path. For this path, we need to consider this case, that whatever the current which is flowing here is flowing to the arm CD. Okay, I3 will be equal to I4, and we know the condition that what is the voltage drop across this E4? That is IC upon omega C4, and which is also equal to IR upon R4. Okay. We know the condition that this voltage drop I2 R2, which is equal to E2, and E2 is also equal to E4, right? This E2 is also equal to E4, and this E4 is equal to IC omega C4, IC upon omega C4, and which is also equal to IR R4. Okay. Now, this is E2, E4, and this is E1, E3. Now, if you observe this is the voltage drop across the capacitor. If this is the voltage drop across the capacitor, where will be the current? Current will be 90 degree to this line, right? So, this is IC. Current IC will be 90 degree to this line. Okay. And what about current IR? IR should be in phase. IR should be in phase with respect to this. Now, what is the resultant of IC and IR? That is I4. I4 is equal to IC and IR, right? So, this is my IR. So, let us write the resultant. This is my I4, and this I4 is also equal to I3. This is the resultant. Okay, why I am writing I3 here? Because this voltage drop, that is across E3, I3, R3 is here. So the current should be in phase with this. Now, coming on to the last part, that is the overall supply voltage E. Okay, the overall supply voltage E, which is equal to either E1 plus E2 or E3 plus E4, which is equal to E1 plus E2 or E3 plus E4. Now how to write the final expression here in the phasor diagram, that is the resultant waveform for E. So this is, if we consider this point, this is E2, E4, and if I consider this point, this is E1, E3, the resultant of these two, right? So I will extend this. Similarly, I will extend this. So this should be parallel to this. Now, this will be the resultant. That is E, which is equal to E1 plus E2 or E3 plus E4. So this is how we'll write the phasor diagram by seeing the circuit. Thank you.